Adopting new technologies is risky. If they fail, they can seriously hinder the effectiveness of your project. On the flip side, avoiding new technologies is also risky. New technologies typically are more efficient and solve a lot of the problems that old technologies have, so you might be sacrificing your efficiency if you don't go for these new technologies. Svelte is a new web framework taking the place of other frameworks kind of like React, Vue, and Angular. While relatively new, it's quickly become one of the most loved, scoring among the top loved and highest in developer satisfaction among all web frameworks for the past 3 years in a row. In this video, I'll share some of the factors and data points that went into my own decision for deciding that Svelte is better than React, and then adopting Svelte into my own projects. I'll also talk about some of the acute risks that I'm monitoring to hedge my bets with Svelte. First area I want to compare is simplicity. Simplicity makes code easier to understand, and that has a lot of benefits for a code base at scale. It's easier and faster to create features. There's less bugs in the code that are actually pushed, and it's easier to onboard new members to the team and to the code base as well. Now, there are two big differences in the simplicity provided by Svelte versus React that I'm going to go into. The first is in the code style. The form of the code that you'll be writing in Svelte is far simpler than the code that you'll see in React. The first thing that you'll notice when looking at a Svelte file is that it basically looks like a normal HTML file. There's some inline code and there's some inline CSS, but generally it's exactly the same as what you'd write outside of Svelte. This is useful because it means that any previous web experience you may have is pretty directly transferable over to the Svelte codebase. Here's a quick example of displaying an H1 tag in Svelte. It literally is just an H1 tag. Now, if we compare this with React, which has its own domain-specific language in JSX, we can quickly see how the complexities start to diverge. JSX mixes its own rules in with standard web technologies, making it kind of hard sometimes to figure out where the divide is. Will something act like it normally does on the web, or will it act with React's specific flavor? This gets even more complicated when we start to think about lifecycle events and how the virtual DOM doesn't necessarily function like we'd normally expect a normal web page to. This means longer learning curves when you're coming from or going to standard web technologies with React than you'd find with Svelte. The differences in complexity become even more pronounced when we start to do things that are more complicated than just displaying an H1 tag. A great example of this is when we start dealing with state. Now, apps need to hold on to state to kind of remember things on the front end. So this could be like the username that's loaded, or maybe it's the items that you selected in your cart. The React ecosystem doesn't have any one standardized way to deal with state. And this means that there's a lot of libraries that are trying to do the same or similar thing, but in many, many different ways. In the past few years, React did add its own form of state management with hooks, but that brings with it its own problems. So either you go with the state handling solutions that were available, and that means you have to choose from a wide array of different state handling libraries managed by third parties and that do things in vastly different ways, or you go with React's built-in hooks, which use a programming paradigm that you basically don't see anywhere else in programming. Both of these lead you to developing code in an unfamiliar way and in ways that don't really transfer to other programming that you'll be doing. So this means more learning, more opportunities for gotchas and bugs, and generally less producing high-quality code as you ramp up. Svelte takes the opposite approach and gives you an opinionated, simple way to deal with state right out of the box. The code looks almost exactly like normal JavaScript. You create a variable, you set a variable, and voila, that value is available for your web page to use. Because it's so simple and acts just like we would expect a normal JavaScript function to work, there's a very low learning curve, low barrier to entry, and much less risk of us introducing a lot of bugs or gotchas due to inexperience. This simplicity means better and faster code for your projects. Now, another big factor to weigh when you're choosing a technology is its speed. Oftentimes, we will see that with increased simplicity, we reduce speed or performance of this technology. At scale, speed can be the difference between performing gracefully under load or having our systems fall over and crash. The first aspect of speed that we'll be looking at is performance. So if you've got some service that is serving thousands of users at once, then performance can be a big deal for you. It can affect the quality of your user experience, save you money on hosting bills, and even keep your system from falling over under high load. Now we are comparing front-end frameworks, so really when we're talking about performance, this load is going to be centered around either the user's browser or around the edge of your service. The service edge will mostly be doing the job of transmitting payloads of your websites to your users, or maybe even performing some server-side rendering if you've enabled that. So when we scope down the idea of performance to these, the real impacts of this is going to be on the experience of your users on your website, maybe your SEO as Google takes into account performance, and then the amount of egress, the amount of data that you are transferring out of your system, as that can be a heavy cost center for a lot of hosting setups. Now there's a lot of people out there who are super into performance, so we actually have a wide array of performance benchmarks to start looking at. Here we can see Svelte stacked up against React, Angular, and Vue, some of the biggest competitors in this web framework landscape. Now there's a lot here, so I'm not going to go into each and every one of them, but if we just take a glance at it, we can kind of see that Svelte is outperforming these other web frameworks in a lot of different exercises. Even in those ones that it's not winning in, it's still being a close competitor. What this means for your users is that they will be experiencing snappier experiences on your website, and that Google might treat you a little bit more favorably as your site performs better. Now bear in mind that these are in milliseconds, so depending on whether or not your front end is actually the bottleneck in your system, this may or may not help you too much. Now aside from the actual snappiness and responsiveness of the framework, there's another big factor we can think about when we think about front end performance. And that is payload size, or really the size of the code that we need to download to actually use this framework. Now, this is important because when you use a framework in your own code, this actually means that the user's client, maybe it's their browser or a web app, will need to download this in order to actually run your code, or in this case, see your website. Now, this act of downloading requires some sort of bandwidth to take place. So if they are not in a very fast network condition, or maybe they're bandwidth constrained, or maybe you are just getting a lot of page users, this can really add up for both the user's experience and your own costs for egress. Now, if we look at the full package of React with React DOM, which enables DOM manipulation, we see that it comes out to about 42.2 kilobytes. When comparing that with Svelte, which is only at about 1.6 kilobytes, we can see that it's about 96% smaller, which is very significant. So we could totally see some improvements here if we switch from React to Svelte just for the payload size, both in how fast web pages load for your users and how Google will rate the performance of your site, and perhaps even in your own hosting egress costs if you are serving websites at scale. Now, while this comes up a lot in performance conversations, I do want to mention that we should take this with a grain of salt and put it in perspective. So while there is a large difference between the relative size of Svelte and React, 42 kilobytes is actually relatively small in the modern web landscape. So if we just head to a few sites, we can actually look inside of Chrome DevTools and just see how big these websites are to download, and that will help us put these frameworks into perspective. So the standard Google homepage, which is touted as like a very performant site itself, is about 986 kilobytes. So even this simple web page is about 23 times the size of React that we're looking at here, which goes to show you that this decision here won't make a significant change, even if it is sizable. The next big category of speed that I want to go into is dev velocity. Now, I know a lot of devs like to go into, performance and like compiler and all these like nitty-gritty details of how things kind of stack up and compare against each other. And that's fine, and it is really important, and there is some significant wins to be gained here. But I'd argue even more important than all of that really comes down to the developer velocity of a given framework or a given technology. My reasoning is that with modern cloud technologies today, it's relatively easy to scale up to hundreds of thousands, even a few million concurrent users just by scaling out. As long as your service has generally average performance and you're not doing anything terrible there, it's not going to be a problem. Even if it is a big problem, often the biggest wins are going to come from simplifying your code and making sure it's doing what you actually think it is, not saving 40 kilobytes on every single request. It may cost you more to host this average performing code. Oftentimes it's going to cost you magnitudes more to actually hire and maintain a full-time developer. Due to the simplicity wins of Svelte over React, I think Svelte wins by a landslide. in terms of the speed and therefore the cost to build new features, onboard new developers to a project, and maintain existing projects for years to come. Now, Svelte is still a new technology, so we'll probably need to see more real-world examples of real projects using this to know for sure. But if you look at a lot of the languages that are the most popular and most used today, you will see that simplicity is a major driving factor of these. Great examples are Python and JavaScript, which is used by most developers many years running. Now, earlier I mentioned that adopting new technologies is very risky, and I don't want to discount that. Adopting Svelte, which is a relatively new technology, is a very risky proposition. So I'm going to share what some of those risks are and kind of how I'm thinking about managing them. First big risk to adopting Svelte, I think, is low adoption and community. In 2021, only 20% of surveyed web developers said that they've ever used Svelte before. This lags behind React, Vue, and Angular by 30 to 60%. What this means for a software project is that there's going to be less code libraries available for you to use. You'll have less Q&A available, less examples on things like Stack Overflow or GitHub, and you'll also have less support from some of the technologies you know and love, for instance, IntelliSense on VS Code. And this will probably continue to be a problem until Svelte gains more traction. On the bright side, Svelte has continually placed in the top most loved and satisfying languages above all these other web frameworks that I just mentioned. So while the community is small, and you might have to work a little bit to get things to work with Svelte, it doesn't seem like that's actually affecting developer satisfaction at all. The next big risk I am watching is the stability of Svelte. Now, Svelte is still relatively new in terms of maturity. So it's been around for similar amounts as these other web frameworks, but it hasn't really matured into a solid framework or ecosystem. So far, it doesn't have the backing of any huge enterprise organization. And this means that in the time that it's been alive, it hasn't had as much code push, it hasn't had as much code reviews, it hasn't had as much design discussion or strategy discussion, which generally means that the current state of it is just a bit softer. The foundations aren't as strong, we don't know exactly what direction it's going in, there's more risk of change, and particularly change in a negative light, than we might see in some of these other frameworks today. The difference between Svelte and these other frameworks, of course, is exacerbated when we think of React and Angular, which are backed by Facebook and Google, some of the largest companies out there. Now, that said, this lack of support doesn't really seem to have hindered the project so far. The library has remained remarkably mission-driven and has really stayed a lean and mean web framework for the modern age, beating a lot of these large enterprise-backed frameworks at their own game, mainly around performance and dev velocity. But this is still something to keep track of, because if we don't have a lot of stability, then we can't really say with much confidence what direction this library will end up in, and it is very possible that you wake up one day and the maintainers are just no longer maintaining it. For some points in Svelte's favor, we are seeing it being adopted into more large organizations. For instance, IBM and Square are starting to use it in their own projects. It has a growing donor list of individual developers who want to support the project. Universal has started to sponsor projects in the Svelte ecosystem. They're the people that also helped sponsor Next.js and Nuxt.js, which really boosted the simplicity and power of picking up any of these web frameworks. So while Svelte still doesn't have huge adoption or backing yet, there are a lot of signs that it is growing, and I think that those signs point to it continuing to grow. I typically consider myself a back-end engineer, and when I do venture into the front end, which is mostly by necessity and just because people like to use websites and not command line interfaces, I like things to be fast and simple. For me as a developer, for my users. Svelte provides that simplicity without losing any of the modern performant features that I expect from a full-fledged web framework. In fact, in many cases, it does it better than the leading, most popular used frameworks out there today. So for me, Svelte is the right choice. All the benefits and none of the complexity. In fact, I'm so bullish on Svelte that I decided to migrate my SaaS boilerplate Cloud Seed from using React and Next.js over to Svelte and SvelteKit. The goal of Cloud Seed is to make it easy for any developer to spin up a full-fledged software as a service website in minutes. That means it has authentication, data models and migrations, and checkouts and subscriptions all built in as soon as you set it up. Cloud Seed needs to be simple and performant so that any developer can use it, and so that they can scale their own business to their first 100,000 or million users. You can learn more about Cloud Seed in this video and get your hands on the fully functional, fast code base, including a full website built with Svelte and Svelte Kit at the link below.